Hello, Washington Liberty Chemistry students. This is your Unit 3 lesson on atomic anatomy. So just as a small assessment of what you might remember from previous courses, copy and try to fill in this table about the subatomic particles that make up an atom. And again, you'll notice that there are 3 rows, so there are 3 subatomic particles. And I would like you to put what you think their mass is in something called atomic mass units, their charge, and their location within the atom. You might want to pause the video to do that, and then we'll check it. So you should have done this. The 3 components of the atom are the proton, the neutron, and the electron, and they're called subatomic particles because they make up the atom. Their mass is measured in something called atomic mass units, which is a very, very small unit. In fact, one atomic mass unit is 1.66 times 10 to the negative 24th grams. So they're very, very small. So we give that quantity the name 1 atomic mass unit. A proton is about 1 atomic mass unit. Not quite exactly 1, but for our purposes, 1 works. The charge on a proton, protons are positively charged, is +1 or +1. And the location of a proton is in the center of the atom in the area called the nucleus. A neutron also is about as massive as a proton. It is 1 atomic mass unit. However, it has no charge. It is neutral, so its charge is 0. And again, it is found in the center of the atom in the nucleus. The electron is insignificant in mass compared to the proton and neutron. We usually count its mass as 0. This is its exact AMU mass, 0.000544, and you can see if you multiply this times this, it would be a much, much smaller number. Its charge is -1, and it's found in an area outside of the center of the atom, sometimes called the orbitals or the orbits, oftentimes called the electron cloud. Let me show you sort of the classic picture of what an atom is portrayed. So what you can see here is we have a nucleus in the center, very small, dense nucleus in the center. In the nucleus, there are 2 particles, the protons and the neutrons, that are roughly the same size. Now, they have mass. And outside of the nucleus is what's called the electron cloud. And the electrons sort of whiz around out here in what are called orbits or orbitals. And we're going to learn a lot more about how this is structured later, but the vast majority of the atom's mass is found in this small, dense nucleus. Most of the atom is this electron cloud in terms of volume, and so most of the atom is considered empty space. So we need to do a couple of definitions. The atomic number is known as the ID number of the atom. It is the number of protons in the nucleus. And you'll see on the periodic table that the atomic number is found right underneath the symbol on our SOL periodic table. And it actually is the number of protons in the nucleus. And that is how atoms are identified. All atoms of the same element have the same number of protons. So if for some reason you were able to pull out an atom and look way, way down in the nucleus, the way you would figure out what the atom was would be by looking at the number of protons. And so, for example, if I looked into the nucleus of an atom and I counted 14 protons, I would know that that atom was silicon. On the other hand, if there were only 7 protons, then that element would be nitrogen. Every element that has 7 protons is a nitrogen, and every element that has 14 protons is silicon. It's the ID number of the atom. So we're going to also learn something called the mass number. And as you know from our first slide, the only 2 subatomic particles that really have mass are the protons and neutrons. And so to get the mass number of a particular atom in atomic mass units, you just add the number of protons to the number of neutrons. And this is the way we tend to show a particular single atom. I pulled out an atom, it's hydrogen. I put the symbol here. Up here in the left upper corner, I put the mass number, and the mass number would be protons and neutrons. And down here in the lower left corner, we put the atomic number or number of protons. Now, sometimes this one is not seen. Sometimes we only put this because the symbol itself, you can look on a periodic table to figure out what the atomic number is. But this is the symbol of a particular atom of hydrogen that has a mass number of 3 and an atomic number of 1. Now, I wonder if you could figure out how many neutrons are in this nucleus by looking at these two numbers. Do you have any ideas? So we're going to talk about something called an isotope. Now, all atoms of the same element have the same number of protons. However, they might not have the same number of neutrons. And so the definition of an isotope are atoms of the same element that have different numbers of neutrons and therefore have different masses. For example, there are 3 common isotopes of carbon: carbon-12, carbon-13, and carbon-14. And the only difference you can see here, you can see carbon-12 has 6 protons and 6 neutrons and 6 electrons. Now remember, the electrons don't add any mass. So the mass number of carbon-12 is 6 protons and 6 neutrons is 12. And so you can see that this number right here in this, this name tells you for this particular atom that there are 6 protons and 6 neutrons because the atomic number of carbon is always 6. Now here's carbon-13. We know carbon has 6 protons, so if it's carbon-13, and that's the mass number here, which is protons plus neutrons, we can see this particular atom of carbon has 6 protons and 7 neutrons. 7 and 6 add up to 13. Carbon-12 and carbon-13 are isotopes of each other. Their isotopes are atoms of the same element that have different numbers of neutrons and different masses, mass numbers. So you can also see we have carbon-14, and again, the only difference is there is 1 more neutron. So protons plus neutrons give you the mass number. And again, remember, we have electrons, but those electrons are so insignificant that we do not count them towards the mass. So there are a couple of ways of writing isotopes, as you've kind of seen. One way is this symbol dash mass number. And you can either put carbon-12 or C-12 or C-14 to indicate the 2 of the isotopes of carbon. Another way to write this is mass number symbol. So you can write it as 12 with the 12 up here in the upper left corner or the 14 carbon. Now, here's again written in the same way. Both of these represent a carbon with 6 protons and 8 neutrons. Here is the mass number, or here is the mass number, and here is the atomic number. Now, isotope symbols can be very useful because the number of neutrons is going to equal the mass number minus the atomic number. Remember, the definition of the mass number is protons plus neutrons. The definition of the atomic number is protons. So protons plus neutrons minus protons gives you neutrons. So can you figure out the number of neutrons in these isotopes of uranium? Uranium has an atomic number of 92, and there are 2 isotopes of uranium. They're actually kind of interesting. Uranium-238 is by far the uranium atom that is most abundant in nature. It makes up like 99% of all uranium atoms. It is radioactive and dangerous, but it is no good for making atomic bombs with. On the other hand, uranium-235 is known as fissionable uranium. It is lighter and more active, and it actually can be used as a fuel in nuclear bombs. Fortunately, in order to obtain enough 235 in order to make a bomb, you have to mine a tremendous amount of uranium and then refine and get rid of the uranium-238, or at least a lot of it, in order to have something that is reasonable for a bomb. So let's see if you figure this out. Have you figured out the number of neutrons in isotopes of uranium? Here's our mass number. Here's our atomic number. Do you remember what to do? So you can see here, they both have 92 protons, but 92 plus 146 will give us 238. So uranium-238 has 146 neutrons, while as uranium-235, which is a little bit lighter, has only 143 neutrons. Okay, one more definition. Ion. Now atoms, and we've just been talking about atoms, are electrically neutral. And that means that protons, which are positively charged, will equal the electrons, which are negatively charged, because the 2 cancel each other out, and an atom will be left with no net charge. However, ions are charged atoms. And we have two kinds of charged atoms. We have ones where you have more protons and ones where you have more electrons. Now, a cation, not a cation, a cat, like a kitty cat, a cation, you can kind of remember that because the T in the middle kind of looks like a plus sign, has more protons than electrons. An anion is negatively charged. And again, the N in the middle can maybe have you remind you of negative. So the T in the middle kind of looks like the positive plus, and the N in the middle for anion is the negative. And in an anion, you have more electrons than protons. Now, the way an atom becomes an ion is by gaining or losing electrons. So a cation will lose electrons in a chemical reaction, and an anion will actually gain, and that's how they get their respective charges. So the key here to determine the charge on an ion is the charge will equal the protons minus the electrons. Okay, it's actually adding the two together, but like adding a negative is the same as subtracting. So let's see if we can practice this. A sodium ion has 11 protons and 10 electrons. So what is its charge? And be sure you put whether it's positive or negative. And is it a cation or an anion? And a chloride ion has 17 protons and 18 electrons. What is its charge? And is it a cation or an anion? You may want to pause the video and see if you can get that before I show you the key. Okay, so here is the key. We have a sodium ion has 11 protons, which are positive, and 10 electrons, which are negative. So if we use this formula to add together all the charges, 11 positives and 10 negatives, which is like subtracting, we get 11 minus 10, so the charge is positive 1. And notice we do put the symbol and we do put the number. Is it a cation or anion? Well, since it's positive, has more protons than electrons, it's a cation. A chloride ion has 17 protons and 18 electrons. Again, we are adding up the charges. And so 17 protons minus 18, 17 positives and 18 negatives give us negative 1. Again, we write the symbol, positive or negative, negative in this case, and the number. Is it a cation or anion? It's an anion. Now, here is the notation for the cation sodium 23. That has 11 protons, 12 neutrons, and 10 electrons. We can see that the mass number, which is protons plus neutrons, would be 11 plus 12 would give us 23. That's up here in this upper left corner. The atomic number, which is the number of protons, is 11. Here's the symbol, and the charge is up here in the upper right corner, and it includes both the number and the symbol. And again, how do we get plus 1? Well, 11 protons minus 10 electrons gives us 1 extra proton or 1 extra positive charge. Now, I'd like you to pause the video and see if you can fill in this chart. If you have notes, you'll be able to fill in right from the notes. You're going to possibly need your periodic table in order to do the two here. And pause it, try it, and then check yourself on the next slide. And here we go on the next slide. So this first one is lithium 7. You can, if you look on the periodic table, you'll notice that its atomic number or number of protons is 3. The mass number from this symbol is a 7. Okay, we're not getting it from the periodic table, we're getting it from the symbol itself because we know they're different isotopes. The charge, because there's nothing here, is 0. Now, atomic number is number of protons, so that's going to be 3. The mass number is protons and neutrons, so 3 plus 4 is 7. And then the number of electrons, since it's neutral, has to equal the number of protons. So this is just an atom. Now here's a symbol for sodium. Now again, a lot of times they will omit down here, what you would found here is that if the atomic number is 11, it would be sodium because it has 11 protons. You can see up here it has a plus 1 charge, which means it has 1 more proton than electron. That's why there are 10 electrons. And because the mass number is 23, we have 11 plus 12 gives you 23. Here's sulfur, atomic number 16, which is the same as the number of protons. Mass number is up here, 32, so 16 and 16 is 32. Now it has a charge of 2 negative. Notice how it's written here slightly different by what we did the charge, just convention. So you can see you have 2 more electrons. So we can't change this. 16 minus 18 gives you negative 2. This is an anion because it has more electrons. And then this one did not have any charge, so we know protons equal electrons. Its symbol has a 37 in the mass number, so that means 17 plus 20 gives you 37 and no charge. So that is your lesson on atomic anatomy.